This
Thanks, Krish.
conference will now be recorded.
Yeah, so we are going to discuss about these topics. So let's start the topics. So the first one, which we are going to discuss about undoing the changes. Right. So that these things will be happen many times to the developers or to the DevOps folks. Right. Like we are going to do some changes and we are going to commit the changes and finally we are going to uh, confirm that those changes should not be go to forward. It should be reverted. It can be happen, right? Many times it can. So now either developers will ask you to revert the changes or by your side, like means I did the changes, I committed as a DevOps guy, I want to revert it. Both the cases. If the developers are not able to revert their changes as a DevOps guy, we need to help them. And also for our side, right? If we are doing our changes, we want to revert it, we need to do our changes to be reverted back. Right. So in our Git, in multiple ways, like there are certain stages are there. So if you are in one stage, you can revert the changes very easily. If you are in second stage, it like two more commands you need to enter to revert the changes. If you are in third stage, then some other process you need to follow. Like based on the stages, the changes can be reverted by using the methods. I can say the commands. Okay. So let's see one by one the stages wise, like stage one, stage two, stage three. Then how we are going to revert those changes on the stages wise. Okay. So let me connect to the server. Okay. So now here I have a repository called git repo. Right. So in the repository, I am in the branch. We want something with there. Okay. So better let me switch to master branch. Git checkout master. Right. So to switch any branch, checkout is the command. So I don't see any master branch in this repository. Git branch. Okay, fine. Okay. So for easiest way, let me create a new repository. On that repository, we'll see this use case. Okay. So what I will do, I am going to create a directory mkdir git revert. Now this is a normal directory, correct? So I am going to convert this normal directory into a repository. Git init. Next, so now touch sample.txt file ls. Now git status process will be remain same, no change. Git add, git commit -m sample file is created. Right now, git status working tree is clean. Now you can see a branch will be created automatically with the name master. That is also fine. So now here I would like to see the logs, git log. I can see a commit. A commit is created. Right. So now on this repository, I'm trying to perform some other changes. So right, some other changes in the sense I'm going to add few lines into this file sample.txt. So vi sample.txt right here. This is first line. This is second line. Something. Save. Git status. Right. So just now I have added two lines to the sample.txt file. Right. So now I'm looking for the status. Right. So when I check the status, the changes has to be staged like untracked to tracked. So this is the stage one. As I said, we can revert the changes based on the stages. Now this is the stage one. At this moment, I don't want to move the changes forward. Simply I want to revert back. I want to revert it. Right. So because whatever the changes I did, those are not belongs to my requirement. By mistakenly, I have done that kind of changes. I don't want to go forward to with the changes. Simply I want to revert it. Right. At this stage, if you want to revert it, there you can see a command git restore. Right. So now with the help of the git restore, we can revert the changes. Right. This is the stage one. Right. We are not yet moved to the staging area also. Right. We know there are such right, like working area, then staging area, then your remote area. Right. So when you run the command git add, that will be moved to the staging area. Correct. So now as part of the architecture. So now here we are at the working area, right? In your local machine, on your workstation. At this moment, I want to revert the changes simply git restore, then the file, right? My file is sample.txt, right? So I don't want to take the changes forward. Simply I want to revert it. Right. So now let's see git status. Now see on the branch master, working tree is clean. Now let me open the file cat sample.txt. No changes. No, the two lines are gone. Right. So means here we are not yet created or generated history. Right. So no commit is happened here. Before the commit only, I am reverting the changes. Is the stage one. Right. So now I am going to take again the same changes and we'll move to the stage two. Right. From the stage one to stage two, we'll move to the stage two. Okay. Right. So again the same process I am going to repeat. So vi sample.txt. Some again two lines are added, right? So now git status. Again I can see here the selection take forward or revert. Right now I'm going to take forward. So git add sample.txt. Now git status. Right. So now here you can see now we move to the stage two. Nothing but right. I have moved to the staging area from the nothing but I have ran the git add command. So now my suggestion is save the changes. Right. Create the history, generate the history. The next step will be next step will be or bring back, revert it. Right. Now at the stage two, you can take it forward or you can bring it back. Okay, the changes. So now from this stage, if I want to revert the changes, the command will be this one. Right. Let's see. So git restore hyphen stage, then the file name sample.txt. Right. So now let's see git status. Right. The observation. It right. We are at the two levels. The first level is the changes and the second level is moving to the staging area, nothing but git add command. So now when the moment I reverted it bring back to the one step back means it moved from the commit stage to your git add stage. Now at this moment it is going to give an option to you, right? You think these changes are not the proper one as part of the requirement, I want to bring it back. At this moment it's going to give an option, okay, so that you can modify the code again, then you can take it forward instead of completely erasing the data. Instead of completely erasing the data, it will be give you the option to you can modify the data still. I'm going to give you the data, go and modify it, then take it forward at this moment. So that's what here when I run the git restore, it bring back to one step, nothing but before the add command. It bring back to before the add command, nothing but on your workstation, on your local. So now here I can see the changes ls cat sample.c, still I can see the changes. Right. So now here again you can modify. Suppose the second line should be the third line actually. In the content, the second line should be this is third line, but by mistakenly I have given as a this is a second line as an example. So now what I will do, I will modify the file. Then I will come here. Then here I am going to add as per the requirement. Then save it. Then git status. You can take it forward by running the git add command, then like that, right? So that you are not going to lose the data, still you are going to have the data handy, then you can modify it, then you can take it forward. No, here the situation is no, I don't want to have the data. I want to erase it. I want to start freshly. It is completely messed up, right? So now here the situation is you don't want to maintain the data, right? You don't want to modify the existing one, you want to start freshly, so that you want to clean up everything. To clean up everything, simple again, you need to run the command restore. So two commands has to be executed if you want to clean up everything. Where at this moment? At this moment, if you want to clean up everything, the first command will be this one, right? One time, right? Sorry, this one, git restore. Then the second command you need to run this one. Two commands you need to execute it so that completely the content will be cleaned up, whatever you have done, the changes, right? So now here, git restore sample.txt file. So now the data, whatever the changes I have done, those are gone. If I see the file, it's an empty file. Right. This is like this, we can consider it as a stage 2, right? So we have seen at the stage 1 how to revert the changes. If we are at the stage 2, how to revert the changes. But both the stages still not generated any history. Usually the problem will be once the history is generated, at that moment you need to revert it. Once the history is generated, if the history is not generated, simply I can remove the like completely I can delete the directory, then first I will clone the directory freshly so that I will not having the changes. But these are the process. You don't want to delete anything like a repository and clone it freshly. You can handle it by using these commands. Right. So now if the history is generated, if the log is generated, then how we are going to revert the changes? That is at the final stage 3. Okay. Let's see. So now if the history is generated, then how we are going to revert the changes along with the history, like along with the commit IDs. Right? History means commit IDs. Along with the commit IDs, how we are going to revert the changes. So for that, we have 3 types. Reverting the changes. Once the history is generated, then how we are going to bring it back. Right? So those are nothing but in 3 types, in 3 ways, we can revert the changes once the history is generated. Those we are going to call as a reset soft, reset mix, reset hard. Soft, mix, and hard. By using 3 options, we can revert the changes once the history is generated, once the commit ID is generated. Okay. So out of the three, nothing but the soft, mix, and hard. Mix is the default one. Soft and hard, we need to provide the options. For the mix, you don't require to provide any option. By default, the gate will take it as a mixed when you are trying to revert the changes. Okay. Now see, so how we are going to use these 3 methods to revert the changes, even the history is generated. Okay. Let's go to our repository again. Git status. Working tree is clean. We are good. Right. So now again, I am trying to modify the data file. And saving it. Now git status, untracked stage, git add, then save it, git commit -m, first line added, some message. Right. So now here, when the moment we executed the commit command, the history will be generated. Right. So I'm going to generate the commit ID, nothing but generating the history. Enter. Now git status working tree should be clean because we have saved it. Now I'm going to see the log. Git log. Right. So now this is the first commit, sample file is created, and this is the latest commit, first line is added. Now I can see my head is pointed to the latest. Right. So now the changes, whatever I have made it, those I want to bring it back. I want to revert it. Right. So now here we cannot use the restore commands. Those restore commands are useful before the commit, before the history is generated. But once the history is generated, you cannot use those commands. If I see the status, it is not going to give you any selection because the working tree is clean. So there I am going to use the reset commands. The git reset command is going to use to revert the changes once the history is generated. So now in the reset, we have multiple options. One is the soft, and the second one is the mixed, and the third one is the hard. Now let's try to see one by one. how these options are going to work. Okay, right. So now here the first one I am going to use the soft one, reverting the changes by using the soft option. So now git reset to use the option hyphen hyphen, then the option name soft. Now here what I need to enter, right? So here we need to make sure, okay, so these changes are messed up. I don't want to have these changes. Then which changes you want to maintain, which change you want to make it as a latest. So now here this is the latest commit id, latest, this one, this change is the latest. So now you don't want it, so now which one you want to make it as a latest. So now here out of two I want to make this one as a latest, means I don't want these changes, right? So now here whatever the changes you don't want, then which change, which commit id you want to make it as a latest, you need to pick that commit id. So now here out of the two, this is the messed up, so I don't want to have this one, and this is the one, this is the correct one. I want to make my history as a latest with this commit id, not with this. So means I want to remove this one. So now whatever the commit id you want to make it as a latest, take the commit id, then here paste it. So now what the git will do, whatever the commits are there on top of this commit id, like it can be one commit id, two commit id, three commit id, hundreds, 100 commit IDs. It will remove all those commit IDs, whatever there on top of this commit ID. On the above, on top of this commit IDs, whatever the commits are there, those will be erased. It's not like only one commit. It can be n number of commits. It can be one commit or 10 commits or 100. If I give this commit ID means what the git will treat as, okay, this one he wants to make this commit ID the latest. So whatever there, whatever the commits are there on top of this commit ID, let's remove them. Let's remove it. Like the git will be treated, right? So now here git reset hyphen hyphen soft, then the commit id I am going to give, so that this commit id I want to make it as a latest. Enter, right? So now let's see git log. Now here no two commits here, only after the log command I can see only one commit id. Earlier two commits, it removed the history also, the commit id also gone, right? Okay, fine. So now when the commit id gone means whatever the changes I have performed, those should be cleaned up or those should be erased, right? If I remove the commit id means, commit means a change. If I am going to remove the change means obviously the change should be erased, the change should be cleaned up. Let's see. So now here ls, I have the file. Now let me open the file. Still I can see the changes, right? So now here with the help of the soft option, we can remove the history. The history can be erased, but the data will be there again. So now the situation is something like that. You don't want to have the history, but you want to have the content, so that you will modify the content again. Then with the latest content, you want to generate the history. Now when I see the history, I am going to see the latest commit only, not the one, not the commit which messed up. That commit I don't want to see in the history. In that case, the soft will be useful. Right. So now here you are going to remove the history. The history is gone, but still you are going to have the content, the data. Now you modify the data, then save it again, so that the fresh commit ID is going to generate. That will be the correct one. Instead of, suppose, right, so if I remove the content as well as, then if I want to modify the content again means you need to write the code freshly. It can be a single character change or like a line change or a file change or multiple files, like that, right? So if I have committed, like if I have done n number of changes, now I don't want to lose those changes. Simply a few things just I need to modify it. So there the soft option will be very helpful. It will remove the history, but still you are going to have the content. Go to the particular areas, then modify it again, then save it again. Right. So now see. So git status. Now see, when the moment I ran the soft option, it moved to the stage 2. Right. Stage 3 to stage 2. The your changes. Now stage 2 means you are not yet saved, but you are added it. The git add command is executed, but not yet saved. Right. So now here again, you want to save it or you want to go back. No, I want to go back from this stage. I want to go back. Now the options. right? So the soft, simply what the soft will do, simply the soft is going to erase the history and your changes will move to the stage 2. From the stage 2, again, your choice, you want to go forward or you want to go backward, right? I want to go backward, then simply again run the command git restore hyphen stage, then sample.txt. Now it will move to the stage 1. So if I see the status, now I can see the red color, then again move forward or move backward. Okay, now you know how to go forward, simply save the changes, git add command. Now again go back, git restore, then sample. Now I am going to lose the content also, no content. So likewise this soft can be used, right? Once the history is generated, you want to revert the changes back, but still you want to have the content there, the soft will be the useful one. Now we'll see the next one, the default one, mixed. So how the mixed is going to work, right? So let me do the same, do the exercise same. So now here again I am going to add the file where sample.txt. Now git status, right? Git add git commit hyphen m git status. Now working tree is plain, right? When the moment I ran the commit command, it will be saved and your working tree will be cleaned up, right? So now git log, I can see two entries again. One is the older one, sample file carrier. The second one is the latest. Just now I have completed. Now again I want to revert the changes, right? So when you want to revert the changes, now we can use the reset option, reset command with different options. We have covered already the soft one. Now the second option I am going to cover the default one, mixed, right? So now again, which one you want to make it as the latest? So I want to make the second one as the latest. Nothing but I want to remove all the commits which are above the this particular commit ID, right? So now git reset. For the soft, sorry, for the mixed, for the default one, you don't require to give the option hyphen mix because it is the default one. Simply you can use git reset and the commit ID, right? Since it is a default one, we don't require to give the option hyphen mixed. Then enter, right? Now see, git log, again the history is gone, the first line created, the history is gone. This one I can see the second one as the latest. Now this become as the latest. I can see my head is moved to the second one, right? So now let's see the changes. ls cat sample.txt, right? Here also I can see the content, I can see the changes, whatever the changes I have done on the sample.txt file, right? Now let's see git status, right? The observation, it moved to stage 1, right? So that is the difference between the soft and mixed one. If I use the soft, it moved to stage 2. If I use the mix, it moved to stage 1. That's it. That is the only difference between the soft and mix. Both will be remove the history, both will be erase the history, but still it is going to have the content, but the stages are going to change. If I use the soft, we are going to go to the stage 2. If I use the default, it will go to the stage 1. That's it. No other difference, right? You can now, again, the choice is yours, nothing but ours. If you want to take it forward, then do the changes again, run the command add and run the command commit, then finally close it, or revert the changes from here also. I don't want to have the content, I don't require the content, I want to clean up everything, right? Simply you are going to run git restore. Now git status, everything is clean, cat sample.txt file, I am going to lose the content also, right? So now the soft and default will give an option of still you can modify the your content, but my situation is not like this. I don't want to run the commands again. When the moment I don't want the history means I don't want the content also. I don't want history as well as I don't want the changes also. It's not like run the command git reset then run the command restore. Now simply in a single step In single shot, I want to clean up the history as well as the content. There we are going to use the hard option. The hard is going to use it for use to remove the history as well as remove the content also, whatever the changes you have done. Right. Let's see the exercise again. So vi sample.txt. Some changes I have done. Then git shortcut can be used, right? Git commit -am, first line added. Right now, git status. Working tree is clean on the branch master. Now, if I see the log, again we are going to see two commits. Right, first line added, and this is my older commit. Right, story will be the same. Right, again, which one you want to make it as the latest? This one I want to make it as the latest. So, right, so take the commit ID. Now, git reset -hard, then the commit ID. Right, so now it is going to clean up the commits as well as the content. Enter. Head is now at DA before nothing but this one. So now git log. Right, my head is moved to this one, the previous commit. Git status. Working tree is clean. Right, no nothing, no selections here. Cat sample. Content is also gone. Right, with a single command in a single shot, we are going to clean up the history as well as we are going to clean up the content. Right, so now here the situation will be right. So when you are going to work with the project, right, now the people like the developers sometimes will ask you to revert the changes. So whatever the commits they have pushed it, they want us to revert those commits. So by that time, what we are going to do here is what we are going to do here is we are going to take the data, take the changes into your local, nothing but by using git clone if the repository is not exist, or by using git pull, so that the both your remote as well as your local will be in sync. Then once you got the latest changes into your local, then by using git reset hard, this option, we are going to remove the changes, whatever the changes they have pushed. Then once the changes are reverted, right? So now always you guys need to remember whatever the commands you are going to play on your machine, those will be applicable to your local only, not to the remote. Right. So here, whatever the commits I have reverted, those will be applicable to my local, not to the remote. Still, I can see those changes in the remote until unless you push the update. Right. So now here we are going to take the data into our local. Then we are going to revert the changes by using the git reset command. Then whatever the data right now we are having, that will be pushed to the GitHub, so that we are going to remove the history from the GitHub also, not only local. Okay, let's see. So now here the same commands I'm going to perform here, no difference, but just for a use case, I'm going to show you guys how it's going to work. So here, let me take the Ansible repo. Okay, any repository to see the use case. Take any repository, clone. Okay, I think I have the Ansible one. ls. Yes, we have the Ansible repository. So go to the repository and git branch. I am on the master. Just I'm trying to sync both my remote and the local. So already up to date. Git log. Right here, I can see a sample file. Create sample.txt. Readme changes. Some commits are there in my local. So just I want to cross verify with the GitHub with the remote one. Right. So now here this is the master branch. There are 8 commits are there. So I'm going to click on the commit section. So now here I can see this change, right? C3 BF A2B. C3 BF A2B, nothing but the sample file. And this second one is the create sample.txt. Create, right? So same, both are in sync. Sync means you are going to have the same data, you are going to have the same commits, you are going to have the same tags also. Nothing will be changed. So now here, I don't want to have these sample file changes. I don't want this. I want to revert these changes. Simply, I want to have this until this point, until the readme changes, not to have the sample.txt file changes. Right. So now these changes has to be reverted. Right. Then this is the requirement you are going to get from the developers. Like these changes has to be reverted. So now what we are going to do? The first step, we are going to get the latest code from the remote to your local. That is done. Then the second step, revert the changes. Means run the reset command so that you are going to revert. You are going to remove these two commits and you are going to make this commit as the latest. Right. So now here I am going to take a commit ID. Right. Which one you want to make it as the latest. So this is the commit I am going to take. So then git reset -hard. Right. Before going to reset ls. So this is the content I'm going to have. Now git reset -hard, then the commit ID. This commit I want to make it as a latest. Right. Enter. Now head is now your head move to this commit. Nothing but it become as a latest. Now ls. See sample.txt is gone. Right. Daily backup.sh is there. Readme is there. No sample.txt because I don't want it. I want to revert the changes, whatever they have done. Right. So now let's see git log. Readme become as a latest. Right. So now this data has to be reflected. These changes has to be reflected on the remote side. Then only the changes will be gone. Otherwise, it is only to the local, not to the remote. Right. So now if I go here, still I can see the changes. Refresh it. Right. So now here, yes, still I can see the changes. Sample file sample because the changes I have done my local, not to the remote. So now push the changes. Right. To push the changes, the same command git push. Right, push nothing but it will try to connect to the default remote path to right default remote path and default branch. Here master is the default branch and default remote path is as well as ansible repo. So now I don't require to give complete syntax. RAKNF 000. Right. So now here it is not going to allow me to push the changes because some commits are there. Right here I'm going to miss those commits. Right. So here there are two commits are there which are not in my local. That is what my requirement is actually. I want to remove those. But here if I use the normal git push command, it won't allow us because the git is not able to understand because there are other commits are there which we are not going to have. So by that time we need to tell push it forcefully. Yes, because my requirement is I don't want those commits. Right, push it forcefully so that take the my update into my remote. So that git push -f. Right now we can see the data is pushed forced update. I want to make it forcefully, right? So yes, I can see it is updated forcefully. Then if I refresh, readme changes, right? Those two are gone. Now let me go to the repository and here no sample file and commits also from 8 to it becomes 6, right? We are good. So right, this is the only one difference we are going to see when you are going to revert the changes. Nothing but the option we are going to use -f. Otherwise, it won't allow us to push the changes. Right. So this is one observation for us. Right, guys. So this is how we are going to revert the changes by using three options: reset, before the commit ID by using git restore. If I don't generate the history by that time, if I want to revert the changes, simply the restore command can be used. If you generate the history, then you want to revert the changes means there the reset command you are going to use. There are three options again: soft, mixed, hard. Right. So now when you want to perform these changes on the remote side, there the same commands we are going to use, but while pushing, you have to use the option -f. That's it. That's how we are going to revert that. Right. So able to understand or not? Any confusion? Let me know, guys.
Shankar, one doubt.
Yeah, sure.
Actually, when we give this restore and commit ID, right? So it's going to erase all the commits before that, right?
Yes, correct.
Is there any way to revert the changes for particular commit ID? Like
Oh,
I need, uh,
yeah. Yes, yes. Yeah, we have actually. We have that option also.
okay,
Yeah. Yeah, Teja. So now in the reset, we don't have such an option of like a particular commit I want to revert it. Right. So when the moment I give any commit, it's going to remove all the commits on top of the commit ID, whatever the commit ID I have chosen. It's not like particular one like, has to be reverted. Right there, yes, that option we're going to see. Now, apart from the reset, we have one more option to revert a particular commit ID. So the command will be git revert. Git revert is the command to revert a particular commit ID. So now, what is the difference between the reset and the revert? Okay. So again, this is also an intro question for us actually, right? So how to revert the changes? Basically, they will ask. Now we are going to explain with the reset we can do it. Now again, the next question will be, right? I want to revert a particular remedy. Then how we are going to handle? Then we are going to tell revert. Then what is the difference? The next question will be what is the difference between the revert and the reset, right? So now when the moment I ran the reset, simply it is going to remove the history. That's it. In the history, the commits will be gone. But for the revert, it's not like that. We can revert the particular change as well as it won't touch the history. Means the history will not be erased. It is going to create a new commit ID on top of the history so that you can have the a pure history, nothing but. So right. So now at this moment, if someone is trying to verify your data, nothing but the code, when the moment they see the history, there they can find out this revert changes. Now you are going to explain why you revert the changes. Right. So now there, with the help of the revert, you can tell the people like, so this is the problem. That is the reason I have reverted these changes. So now they will understand. Okay, they have performed some changes here. Then later on they have reverted because due to this reason. Clean history. But here in the reset, no, you don't. You will not see why they reverted the changes. Right. Simply it will remove the history. Right. So now here the revert will be the option to revert a particular commit ID, particular commit, and also it won't touch the history. On top of the history, it's going to generate a new commit ID. So right. So that is the difference between the reset and revert. Reset will remove the history, but revert it won't touch the history. Again, it's going to generate one more commit. Let's see how we are going to work with the revert. Right. So here git status. My working tree is clean on the master branch. Git add git stat. Sorry. Okay, fine. Status git commit -m sample file created. Right. So now here a log will be generated for the sample. Vi sample.txt. A line I have added in the file. Then git shortcut git commit -am first line added. Now git status. Everything is clean. Now git log. I can see two commits are generated on top of the readme changes. Right. One is file is created and second one is liner. Now I want to revert these changes. Not this one or not this one. Simply I want to revert these changes. Right. So here when you want to revert the changes, right, or else what I can do, let me add one more commit. So instead of removing the file, I'm going to add one more line. Now three changes I have done. One is file creation, and the second one is first line added, and the third one is second line added. Now I want to revert this commit. Right? So to revert the commit, git revert is the option, the command. Earlier, just now we have used git reset to revert the change. Now I am going to use revert. Right? So which one you want to revert? I want to revert this commit. Right? So now here, this is the problem you are going to face when you want to revert any commits in between, right? So it is going to, because you want to maintain this line, to maintain the data, you don't want this data means obviously you are going to see the conflicts, right? The conflicts has to be resolved. Then only you can take it. Then add and commit it, right? So ls cat sample.txt. Now you can see the conflict, right? So because you don't want to have the change which is in between commits. The first one you want to maintain, the third one you want to maintain, the second one you want to remove it. Means the conflict we are going to see like this. It has to be resolved. Right? So it is some kind of a typical process for us. Right? Then again, this is not our duty to resolve the conflicts of the application code. That is responsible. That is the responsible of developers. If the case will be the DevOps, nothing but your changes, your Docker files or Jenkins files, then that is our responsibility to resolve the conflicts. So for us, we are not going to have 100 lines of change or 1,000 lines of change, right? Our code will be some minimum code. On that, we are going to see only one or two lines conflicts, not like the development side conflicts. Okay, anyway, whatever it may be, now we know how to resolve the conflicts. We have 4 ways, right? So we can use any way, then we can do it out, right? So here, which we sample.txt. So now here I am going to remove this one. Git status. Now the process will remain same. Git add conflict resolve. Now git status. Everything is going git log. Right. So now here we can see the sample file. The first line is there, only the second line is gone, but still you can have the history. Sample file created, first line is there, second line is there, and on top of that, we are going to have our latest commit conflicts. It won't touch the history, right? The commits will not be erased, it will not be removed, right? So now here, if you are trying to handle this kind of commits reverted, then obviously you are going to see the conflicts. That is as usual, right? So if you are trying to resolve, right, sorry, if you want to revert any commit which is in between the history, right? So there we need to resolve the conflicts. So let me show you one more example on the revert so that we'll understand somewhat clearly. Instead of reverting a change in between, we'll take the latest one. So now here again, working real clean, va sample.txt with commit hyphen am and second line. Just I'm trying to generate the history. That's it. The history I'm trying to generate. So second line now. That's it. Now here I have generated 2 more commits. Now git log, I can see after the conflict commit, I can see there are 2 more commits are generated. One for the second line and one for the third line. Now I want to revert the changes. Whatever I have the latest, I want to revert the changes without using the reset by using revert. So now here I'm going to take the commit ID which I want to revert it. Now get revert, then the commit ID. Now it is going to ask you why you want to revert the changes. Message. It is going to ask you the messages, right? So here I'm going to provide the message. This is not part of the current sprint. The changes are not part of the current sprint 12 something. So this is the some message I have given and saved it. Now git status working tree is clean, git log, right? So now the third line, the history is not touched, right? The history is not touched, still I can see the history, third line. But one more commit is generated on top of it by saying reverted the third line, and why the third line is reverted means these changes are not part of the current sprint, right? So now here the history can be maintained. Even though you revert the changes, you can maintain the history so that the people can understand, okay, these changes are moved, but they after that they have reverted because that is not part of the so and so sprint, something like that. So now here open the file cat sample, right? Now we can see the third line is gone. First line and second line I can see no more third line, but the history I can see here. So likewise revert can be used, right? So now you can revert the changes, but is not going to touch the history, right? And also you can, by using the revert, you can also revert the a particular commit also, not like only the latest or top of like 5 commits or 6 commits, like that, like how the reset is going to work. But again we are going to see the conflicts like how we see in our previous example. So right guys, so now these are the commands which we are going to use to revert the changes in our git: restore, reset, and revert, right? So if you are good, I am going to move to the other topic. Any doubts, please let me know, guys. So everything is explained here with the screenshots. So now this is the revert process, right? So now the other topic, cherry pick. This is also very useful for us and also for the interview sake, and they will ask the cherry picks also, right? Here there is a scenario, right? So now here my scenario is I have two branches, like I have two branches, like one is future and the second one is develop branch. Right now I want to merge the future branch to develop branch. Now in the future branch I have some changes. Commit 1, commit 2, 3 commits are there in the future branch, right? When the moment I merged the future branch to develop branch, all the commits, right, whatever the changes you have done on the future will be merged to the develop. So all the commits will be merged to the develop branch. You can see the commit 1, commit 2, commit 3 also. But here my scenario is, right, so I don't want to merge all the commits, okay, right? So now here only I want to take commit 1. I don't want the commit 2 and commit 3 because they are not part of the requirement, or due to some reasons, they don't want to take the commit 2 and commit 3. Only they want to take the commit 1 and they want to push it to the develop branch. It is going to happen. It is going to happen in our real time also, right? Now the developers don't want to push all the changes. They want to push only a particular change. A particular change means a commit ID. Finally, the commit. Right. So now here, how we are going to handle the situation, right? Instead of merging the branch, if I merge the branch, obviously I'm going to merge all the commits. I don't want to have it. I want to move only a particular change, a particular commit. So that process we are going to call as a cherry pick. In our Git, cherry pick is a process, a option, so that you can take a commit one branch to another branch, whatever the commit you want to take it. Right. So now let's see how we are going to take these commits, moving the commits from one branch to another branch with the help of cherry pick. Right. So here, let me go to our repository, git status. Everything is clean. Git branch. I can see master. Right. So now here, I'm going to create a branch called release. Now git branch. Now a release branch is created on top of the master, means release is replica of master now. So whatever the changes are here, I can see the same changes on my release branch also. Correct? Just now I have created it. Both will be in sync. I can confirm it. Master against release. No difference. Right? So now I am going to do some changes on the master branch. Right? So then I want to move a particular commit into the release branch. So now here, touch Ansible, touch Docker file, some file. Now git status, git add, git commit -m Docker file created. Now git status, I can see clean, working tree is clean. Git log, a new commit ID is generated for the Docker file. Fine. So now here I can see in the content, the Docker file is present. Now I'm going to create one more file, touch Jenkins file. Right, so the same thing, git add, git commit Jenkins file created. Now git status, it should be clean. Yes, it is clean. Then git log, I can see two entries now. One is for the Docker file and the second one is for the Jenkins file. Right. So now here, when I trying to merge the branch master to release, so what will happen? These two changes will be merged to the release branch as usual. Right. So now here my requirement is I don't want to merge the two changes. I want to merge only. Merge means I want to take the Docker file only from the master to release. I don't want to take the Jenkins file. The change I don't want to take it to the other branch. So now here you cannot use the merge. If I use the merge, obviously it's going to merge all the changes, right? So there the merge is not going to work. So there the cherry pick is the option. The cherry pick we are going to use to take the commits, to take the changes from one branch to another branch. Now here, this is the one I want to take it. So copy. Which commit you want to take it? Copy the commit ID, then switch to the target branch. Right? Which branch you want to copy? Right? This is the source branch. Nothing but the I want to take the data. I want to take the commit from the master to the release. Now the master will become as a source and release will become as a destination target. Right? So now on my source, whatever the commit you want to take it, copy the commit ID, then switch to the target. Right. So now here my target is release branch. So git branch. I am in the release branch. Okay, fine. So I have done the changes on the release branch. So let me go to the master branch then, vice versa, right? So now here, check out master git log. Here I don't see the changes, right? Now I have done the changes on the release branch, right? So now from the release branch, I want to take it to master, vice versa, right? So now on the release branch, I have two changes. One is the Docker file change, and the second one is Jenkins file. Now I want to take the Docker file change into my master, right? Merge is not going to work because it is going to merge all the commits. So there the cherry pick is the option. So now whatever the change you want to take it out. So now from the source, copy that particular commit. What are the commit you want to take it? Right now, git branch, I'm in the release branch, and git log. This is the log, and out of the log, I want to take this commit ID. Now this commit ID, I want to take it to my master branch, my target. Right. So now go to the master branch. So git checkout master. Now in the git master log, I don't have those two changes. Docker file change is not there. Jenkins file change is not here. Right. Fine. I can confirm it. Now I want to copy. Right. So if you want to copy, git cherry hyphen pick. The command is cherry hyphen pick. Let me confirm the syntax is correct or not. Yes, cherry hyphen pick. Right. Then paste that commit ID. That what are the commit you want to take it to your target. Now this is the commit I want to take it from the release to master. Enter. Now we can see one file changed, right? So now git status, your working tree is clean because I have not done any changes on the master branch. If I had done the changes, then I'm going to see add it, commit it, then generate the history, right? So here just simply taking the data from one branch to another branch. So that is the reason your working tree is clean. Now ls, the Docker file came. I can see the Docker file. The change came into my master. Git log Docker file, the commit ID, but not the Jenkins file one. The Jenkins file commit ID not came into my master branch, right? This is how we are going to handle in a situation like you want to take only fewer commits, not all the commits of the particular branch. There, the merge is not the one because if I merge it, automatically all the commits are going to merge, right? So now here the option will be the cherry pick. Very, very useful for us. Very, very important as for the interview as well as for our real time also. Cherry pick is the one, right, guys? So this is about the cherry pick of the Git, right? So any doubts, guys? Please let me know, right? So if you don't have any doubts, we are good. Otherwise, please let me know, guys, if you guys are having any doubts. Okay, right? So then the other section of the Git, the other option of the Git is stashing. Stash. So what is a stash here? So right, so now here sometimes we are going to have a situation like we are working on a requirement, right? We start working on the requirement, so we are doing some changes. Suddenly your lead or your manager asks you to there is some issue, the server is down, let's go and fix it first. That is a high priority. Now we are in between. Suppose you are trying to write a playbooks, Ansible playbook, or you are trying to write a Jenkins file, CI/CD process. You are in between. At the moment, your boss, your lead asks you to fix the server issue because the server is down. It's a high priority. Now here we are in between of changes. Now here I don't want to save the changes because the changes are not yet completed, right? So now at this moment, if you want to maintain the data, obviously you require to run the commit command so that the changes will be, what are the changes you have done so far, it will be saved. But what will happen here, the history will be generated in the background. When the moment we run the commit command, in the background a commit ID will be generated, right? But what the commit ID is not required because that is in between, the process is not yet completed, my changes are not yet completed. There we have an option of stash, means the data will not be loose, and also the data, for the data the history will not be generated, simply it will take the data into buffer. The data will be moved to the buffer area of the Git. Now do the other work, whatever you have the priority, complete it, then come back, then bring the data from the buffer and start working on that one, so that without generating the history you can have the data in a buffer area. Then you can work with other priorities, then come back and take the data from the buffer area, then continue your work. So that option is available in our Git. That's what we are going to call as a stash, Git stashing, right? So let's see how the Git stash is going to work. So now here I am in the branch master, right? So here for better understanding, it's not like only we need to create a branches or something. For better understanding, I'm going to show you this case. Okay, so here I'm going to create multiple branches. Get branch child 1. On top of the master, I am going to create a branch called child 1. Right now here I can see a child 1 branch is going to create. Right. So now here I am going to switch to the child 1. So I am going to modify the Docker file. Right. So here I have done some changes, nothing but added a line in the Docker file, nothing but the child 1 changes. Now git status. Right. It is an untracked state. Make it as a track. Git add, but don't save it. Don't commit it because my requirement is I don't want to save the data. It is not yet completed. Right. So now simply what you will do, git stash. Right. So now here I'm going to ask the git to whatever the data is there, take the data into the buffer area. Enter. Now we can see saved the working directory and index state is work in progress on child 1. So this is the ID it is generated. Right. So now I'm going to switch to master again. Git branch. I'm in the master. Now again I'm going to create a one more branch, a replica of master with the name child 2. Git branch. Now I can see there is a branch child 2 is created. Let me go to the child 2 branch. Git checkout child 2. Git branch. We can see the child 2 branch. ls again Docker file. I am trying to modify the Docker file here. This is from child 2. Some changes. Right. So now git status. Again the same story. Git add, but don't save it. So now I'm going to run git stash. I don't want to save the changes. Now child 2. Right. So now I'm going to move to the branch master again. Git branch. Right. At the moment again I'm trying to create one more branch called child 3. Shortcut create and switch. Right now I'm in the child 3. Git branch. Right. So ls vi docker file. This is from child 3. Right. Git status. Git add. Again git stash. Right now all the three changes, what are the changes I have done, all the three changes I moved to buffer area. I don't generate any history, simply I move to buffer area. Now I'm right. So now based on the priority I switch it to my other work. There I have completed, then I came back. Now I want to start working with the changes whatever I have moved to buffer area. Right. So now you want to see the buffer area, right? Whatever the changes you move to buffer area, those changes I want to see first. So now to see the buffer area information, git stash list is the command. Stash list will show you whatever you have moved the buffer area, those will be represented with the stash followed by the index positions. Okay. So now 0, 1, 2, right? So whatever the changes you are right. So child 3, my latest, child 2, the previous one, child 1, the last, the older one. Right. So now here, whatever the data you move to the buffer, it will be moved into the index positions of the stash. Now the stash will be maintain the index like an array. Like an array, it's going to maintain the changes. Now you want to go to the child to changes. You want to go to the child to changes. You want to finish it first. That is the out of the three, the child two is the priority one. So I want to go to the child two and I want to finish the changes. So then here, what you can do here is from the buffer, you can choose the index of the child two. Git stash, the command will be git stash apply. Apply is the command to apply and means you are going to take the particular index of the buffer area. Right, which one you want to apply, which one you want to take it? I want to take the child two. My child two is nothing but this is the index. Right, so copy the index position and paste it here. Enter. Right, so now you move to the particular buffer area, nothing but the child two. Now here ls cat docker file. This is from the child two. Right, so now there are three storage points, three indexes are there, nothing but the child one, child two, child three. Now out of the child one, child two, child three, which one you want to take? That can be you applied with the help of index, the stash index. Right, right. So to apply, stash applies the command. I moved it. So now start working on the changes, then complete it and save it. Deal done. Right. So now here I would do right. So here I am not going to perform any changes. Simply I want to go back. So now here what I will do, git restore, and the file name is docker file. So no changes I am going to perform. Simply I am going to revert it. So cat docker file. Right, now the changes are reverted. Right, so whatever the child two changes are there, those are reverted. Now git status, it will be clean. Working tree is clean. Now git stash list. Right, so now here I want to go to the child one. I want to finish the child one too. Child one, then after the child two, I want to go to the child one changes. Now git stash apply, then the index stash at the rate one. Now one is the index position of the child one. Sorry, two. So I need to give two. Two is the index position of the child one. Stash at the rate two. Enter. Now ls cat docker file. I can see child one changes. Right. So likewise, we can move to the data. Data can move to the buffer area. Then you can bring it back by using the stash indexes. This is how we can maintain the data without generating the history. When the moment you want to switch to some other work, so by that time, instead of generating history, simply can take the data into buffer area. Then once your work is done, then come back and bring the data from the buffer area. Then start working on the data. So that is what the git stashing here. Now here, for better understanding, I have created multiple branches and I have showed you this kind of example. It's not like only you have to create the branch and you have to do the stashing. It's not like that. For any change you can move to the stash area. Right. If I have done multiple changes on a single file, those changes also can be moved to the stash area. Nothing but simply when the change is done, git stash. That's it. It move to the buffer area. It's not like it is going to apply only on the branches. Any change can be moved to the stash area. It's a file change or multiple file changes are a branch change. Right. So now here in the stash, right. So here even though I reverted the changes of child to at some point of time, but still I can see the entry here. Okay. Right. So now here in the git when I movement git stash list I am going to use, by the time I can see all the entries. Right. Now here I don't want to see the history here. See the entry here. Once my work is done on the stash one, nothing but on the child two changes. Then from the buffer area also, this entry has to be removed. I don't want it. Otherwise, what will happen if I go to the buffer again I can get the same change. I can get the same change. But I have done already the updated. I have updated my code. I have the latest code. Now if I go to the buffer area again, I am going to take the old code only. Like right, there are 2 lines are there in the buffer area. Then I take the data. Then I have added 4 more lines, means total 6 lines. My new change. Now if I go to the buffer area again, I am going to get the 2 lines only. Right. So this situation I don't want to face it. When the moment I went to the buffer area, I picked the data. That the moment the entry should be erased, so that in future if I go to the stash list, there the entry should not be visible, right? Because I have done the changes for that particular buffer area, particular buffer index, right? So there we are going to use stash pop. Instead of apply, we are going to use git stash pop. So what the pop will do, it will take the data from the particular buffer area. Then in the background, the entry will be erased. In the stash list, the entry will be erased. Right. Let's see here, git status. Right. So here it is not clean. You have to make it as a clean working tree. Otherwise, it is not going to allow you to run the other operations. Okay. So I want to make it as a clean. So now what I will do, git restore then Docker file. So I don't want to move it forward. Simply I have restored it. So now git status. You can see here it's a clean. So now git stash list. Again, I can see all the 3 entries, right? Even though I have done the changes for the child 1 or child 2, whatever it is, child 3, but still again I can see the child 3, right? So I don't want it. So now here what we can do, git stash pop, right? So here git stash pop or apply. The commands will be git stash apply or the pop. So right, both will do the same job. Both will take the data from the buffer area, but apply will remain will keep the entry as it is. The index entry will be kept as it is, but the pop will erase the entry. So that is the difference between the apply and the pop. From the data side, both will do the same job. Nothing but both will take the data from the buffer area to you. But the stash will not touch the entry. Pop will remove the entry. That's it. Right. So now here I'm going to use pop. If I don't mention any stash index like 1 or 2 or 3, by default the pop or apply will pick the latest one. By default is those guys are going to pick the latest one. So enter. Right now here I can see again it picked the latest one, nothing but the child tree. So here if I see cat what is called Docker file, there I can see this is the from child tree. Right. So now git restore. Right. Suppose I don't want to changes again. So Docker file done. Git status, everything is clean. Now try to see the list, git stash list. Now we are not going to see the change. Sorry, I mean to say the entry, because I am done with the change. No more. I don't want to maintain in the buffer area. The change should done. Right. So likewise, the pop can be used to remove the entry from the buffer area. Right. So that is the difference between the apply and pop. Okay. So it is not an entry question case. In the entry, they will ask how to maintain the data in the buffer area. Means I don't want to generate the history. That's what we need to tell. Stash. And but in the stash we have multiple options called pop and apply. Okay. Some like maybe they will ask, but it's not like a mandatory entry question. Right, guys. So this is how we are going to maintain the data in the buffer area when the moment you don't want to generate the history for your changes, but you want to move it out to some other area because those are the priority ones. Right, at the moment you want to make it you want to keep the data in some buffer area, so there the stash will be the useful one in the git. Right, guys. So the next part, the next section of the git will be the rebase. Right. So git stashing, right? So here I have explained everything in the stashing again. You can go to the PPT. Right, the same example I have shown you, child 1, child 2, child 3, all the stuff. Right. So the git rebase. So better before going to that, let's take 10 minutes break, guys.
Sure, Shankar.
What do you suggest? Is it
Okay, okay.
is it okay? Yeah,
Yeah.
yeah. Bet yeah, better let's take 10 minutes break. We'll meet at our 15 minutes break, 11:40. Okay.
40, okay.
We'll come back. We'll continue with the other topics. So here I'm going to stop the recording right now. Then we'll start it again.
This conference will now be recorded.
So in our Git, one of the feature is rebasing. Right. Right. So here, as a DevOps guy, most of the time we are going to working with the history. Right. So we have seen also, right? So going to the particular commit ID and reverting the commit IDs, merging, resolving the conflicts. Like most of the time, you are going to work with the history, nothing but the commits. Right, so in Git, they have given one of the feature called rebase, nothing but we can rearrange the history. Right. So suppose as an example, I have an history like 1, 2, 3, 4. Now I want to rearrange the history 1, 4, 3, 2 like that. Now the series is 1, 2, 3, 4. Now I want to rearrange the history 1, 4, 3, 2. You can shuffle it. You can shuffle the history. And also it is having a future of, right, when the moment I merge one branch to another branch, so whatever the source branch is having the data and the history will be moved to the destination branch, right? But whatever the destination branch is having, it will not be there in the source, right? So now here the rebase will make both in a synchronization order. Means whatever there in the source, that will be there in the target. Whatever there in the target, that will be there in the source. It's going to rearrange those data and the history on both the branches. That is possible with the rebase. Right? So like we have n number of options are available with the rebase. Right, we can rearrange the history of a particular branch. You can synchronize two branches with the help of the rebase. We can drop the commits like how we have seen, like with the help of the reset and revert. How we have reversal changes. Likewise, we can drop a commit from the history by using the rebase. Right, we can squash. You can squash the commits. Like a number of options are available with the rebase, but usually we are going to see like the rearranging of history, something like that, because when you are trying to drop or when you are trying to squash, for sure you are going to see the conflicts, right? Because you are trying to do something in between the history, and those has to be handled. Otherwise it is a mess for us, right? So those are two dangerous things, squashing and dropping. We have to be very careful, right? So now let's see the rebase stuff with few of the examples, right? So now here I am going to run a process. Like I have taken a use case, so that you can understand very easily with the rebase, like how the rebase is going to work. Okay, so let's go and start the use case. So now here I am going to create two separate repositories to understand rebase easily. Okay, so let me, okay. Okay, so here I'm going to create a directory mkdir git merge, some name, some directory name ls. Now we can see it is a normal directory. So now I'm going to convert into a repository. Git init. Right. So will go to, right. So now here the first step I have converted into repository. So now here the second step I'm going to run nothing but creating a file. Correct? That means a empty file. Here I can see a.txt file is created. Right. So then add and commit. Right. Git status. Right. Right. As I said, git add space dot also fine, hyphen a all or a file name. Anything you can give here. Right. So here we are given hyphen a. Take it all. Now save it. Right. When the moment we are going to run the commit command, in the background, the branch will be created with the name master and one committee ID is going to generate. Correct? So git branch. Now we can see a master branch, git log, You can see history also. One commit ID is generated. Right? This is the message I have given. Commit A added a.txt file. The message, whatever I have passed, I can see it here. Right? So now go to the second part. Right? So here, same one more commit ID I'm going to generate. Nothing but history. History I'm going to generate. Right? So I'm going to repeat the commands again. Nothing but creating a file. So now here I'm going to create b.txt file, some file. Then I'm going to add it. Then I'm going to save it. So here added b.txt commit b added b. This is a message just for better understanding. So now here, if I see the log, two entries we can observe, right? Two committed is one is for the a.txt and the second one is for the latest called b.txt. Now if I see the content, we can observe two files will be created. One is a.txt and the second one is b.txt. Fine, right? On the branch master. So now at this moment, I am going to create a branch called future. A branch future is going to create at this moment. Right. So now what will happen? Now the future branch is a replica of master branch. Correct. So means whatever the data is there, that will be there on the future branch. Whatever the history will be there, that will be there on the future branch. Everything will be copied into the future branch. Right. So now on the future branch, I can see the two files and I can see the two commits also. Correct. So now just for confirmation, so I'm going to check out to the future branch. So now I'm on the master git checkout future. So now git branch. Now we can see we are on the future branch. Now if I see the log, the same log has to be displayed here also. Like the same log means commit B, commit A, two commits, right? And also the content should be the same. A.txt, B. Because both are replicas, right? Replica of a master is a future. We can confirm very easily by running the diff command. Git diff master against future. Instead of checking manually, I can check with the command. The command itself will show any difference. It's going to display on the screen. Right? We are good. Now let me switch to the master branch. Now git branch. Right? As per the document, right? At the on the master branch, a.txt is created, b.txt is created, then a future branch is created. So now here I'm going to perform the other changes. Trying to create one more change, nothing but creating a one more file here, right? So let me do the change. So touch c.txt git add. Right now here the commit. Right here c.txt and my commit number is c. Right. So now on the master branch, I have three commits, one for a.txt and one for b.txt or one for c.txt. Three commits. And the content I can see three files, a.txt, b.txt, c.txt. Now the future branch, right? Now the future branch is not synced with the master, right? Because after the branch is created, I have made some other changes, nothing but created a c.txt file on the master branch, which is not going to have on the future branch, right? Now both are not in sync. Right? Let's see git difference master against future, right? The difference is c.txt file, right? That is clear. So now let's go to the future branch, right? So at this moment the file c.txt will not be available on the future branch. The c.txt only be on the master branch, right? So now I'm going to switch to the branch called future. So now git checkout future. Now git branch. I switch it to master to future branch. Now if I observe here, I don't have the c.txt file because after the branch is created, I have made some other change on the master branch. Nothing but creating a c.txt file. So now here I am trying to add some content to the files. Right, whatever the files I am having here, I am trying to add some content. A line a is added to a.txt, cat a.txt, right? Is added, right? So now here, whatever the change we have done, the change I am going to save. Git add, right? Then the message. Commit I have given as a e, then modified a.txt file is the message, right? So now if I see here git log, now this log will be for the future branch, right? Because we are on the future, not on the master, right? If I see the log, we can see these two are came from the master branch, correct? A.txt and b.txt, those are came from the master branch, and this is the change just now I have performed on the future branch. Nothing but some message, some data I have added to the a.txt file, right? So now here three commits. There are also three commits, but this commit will not be there on the master because I have not merged it. The future branch is not merged to the master as of now. That is the reason we are not going to see this change on the master. Again, the c.txt file is not going to be available on the future branch because the master is not merged to the future. Until unless we merge, we are not going to see the other branch changes in the current branch. We know very well that process, right? So now here some changes I have performed, nothing but adding some content to the a.txt file. So now I am trying to repeat the same, nothing but creating a just I'm trying to generate the history for better understanding. Here the concept is not to adding a content. The concept is trying to understand how the history is going to generate, how the right what the branches will look like, then how the rebase and how the merge is going to work. That is the concept here. Okay, right. So now here I am trying to add some more content to the file b.txt. Now git add. The message I'm going to copy from here because some meaningful message we are passing here for better understanding, so that I'm going to give the same message whatever we have on the PPT. Right, the commit, now the commit I have given as a F, then modified b.txt. Now see git log. Now the commit A and the commit B are from the master branch. Commit E and the commit F are from the future branch changes. These two commits you are not going to see on the master branch. That is fine, right? So now let's go to our master, right? So I'm going to switch to the master branch. Git checkout master, right? So now I switch to the master after performing two changes, right? Two changes after performing two changes on the future branch. I switch to the master branch. Now I'm trying to check the history. Git log, right? So now when the moment we are going to give the command git log, we are going to see the commit ID, who is the person did the changes, what date and what time, and what is the commit message, right? So this complete information we are going to see with the help of the log command. I want to see the brief information. I don't want to see all the detailed information. Simply I want to see the just the commit messages, just like that. So now here there is an option, a shortcut called one line. So git log one line is the option, so that it's going to show you the data instead of multiple lines. In a single line, it's going to show you, right? So here BC748B, right? This is the one. BC74, nothing but my commit A. It is not going to show you all this stuff. Simply in one line, it's going to show you, right? So now, right now I can see commit A, commit B, commit C. Nothing but A.txt, B.txt, and C.txt on the branch called master. 3 files are created, right? So now let's switch to the future branch. Get checkout future. Now get log -one line, right? AB, right? AB are from the master branch. At the moment I have created the future branch. Now then E and F are generated on the future branch. Nothing but modifying the A file and modifying the B file. Now this is the history on the branch master, and this is the history on the branch future, right? So now check out the future, check out, right? So now merge the future branch to the master, right? So now here I would like to merge the future branch to the master. Let's see, right? So now here when you are trying to merge the funda, the rule will be you have to be on the destination branch, then run the merge command, right? So now future to master means master is my destination, so you must and should be on the master branch. So now get branch, I am in the future. When you want to merge the future to master means you should be on the master. Git checkout, switch to the master first, then merge it. Now get branch, now I am on the destination branch, right? So now you can run the merge command, right? So get merge future, my source will be the future and my destination will be the master, right? Git merge future, right? So now here enter. Now what will happen here, whatever the changes are there on the future branch, those will be merged into the master, right? This is, it is going to ask you the message, the commit message. So merging future changes into master, some message, the commit message I'm going to pass there. Now the code nothing but the future branch changes are merged to the master, nothing but the a.txt modified and b.txt modified. The line is added, right? A, B, those will be merged to your master, right? Let's see here. So now get log, I am on the master branch. A new commit ID will be generated for the merge, right? So merging future branch, future changes to the master. A new commit ID is going to generate when you perform the git merge command, right? So now here git log -one line, right? So when the moment I merged it, so what will happen here? Whatever the commits are there in the source, those will be merged to the destination. My source is the future branch. The future branch code as well as the history will be merged to the your destination branch called master, right? So now here when I see the log, I can see A, B, C are from the master branch, correct? A file creation, B file creation, C file creation are performed on the master branch. Then modifying of A file and modifying of B file are performed on the future branch. Now when the moment I merge the future branch to master branch, the data as well as the data and the history are merged, right? So now that is the reason I can see, right, modified B file and modified A file commits are came into the master. So right when the moment we ran the merge command, for the merge automatically one commit is going to generate. So the commit is nothing but this one. This is the commit for the merge. Right, total now we can see 6 commits, three from the master and 2 from the future and 1 for the merge. So now let's see the content. There are 3 files, cat a.txt. Now I can see we can see the data also, right? The data also we can see now cat b.txt. These changes are from the future branch. Now let's switch to the future branch. Check out. Now try to see the log git log -1 line, right? So here I can see A, B, and these two are from the master branch when the moment the future branch is created, and these are the changes which we perform on the future branch. Now the observation, if you guys observe here, there is no c.txt file present on the future because we merge the future to master, not from the master to future. When you merge the data, when you merge the branch from the master to future, then only we are going to see the master changes in the future branch. Otherwise, we are not going to see the master changes on the future branch. That's what the merge is, right? So when you are trying to do the merges, when you want to have the changes of one branch to another branch, then only you are going to do the merge. Then only you are going to see the changes, right? So that is the reason we merge the future branch to master, so that whatever the changes we performed on the future branch, those are reflected on the master branch. But we are not merge the master to future. That is the reason we are not going to see the c.txt file on the future branch. This should be clear, right? So now, like if I see in a pictorial way, like the diagram again, so this is how it's going to happen actually, right? So ABC are the master branch commits, commit A, commit B, commit C, nothing but A.txt, B.txt, C.txt. So now at the moment when we created the A.txt and B.txt, we have created the future branch. So now it is split out the future branch. Now AB will be came into the future branch. Then on the future branch we have performed E and F, nothing but A.txt modification and B.txt modification. In between we have performed nothing but we have created a c.txt file which is only on the master branch. It is not going to present on the future. So now once after the changes are performed like E and F, we merged the changes into the master. Now the line is back to the master. So now this G is nothing but our merge command, right? So now on the master we can see A, B, C, E, F, G total. On the future branch A, B, E, F we are going to see only this, no C, no G. Like how the if you try to understand in the pictorial way, right? So now this is a normal merge, no rebase, nothing here. If you try to do some merging, right, then how the history, how the data will be moved from one branch to another branch. The understanding of the data movement and the history movement. So now the same thing we are going to perform, the same use case we are trying to perform with the rebase. Then what is an advantage of the rebase we can understand very clearly, right? So let's try to do the same exercise with the rebase, right? So now I will go to our server. So now I will come out from the git merge repository, cd enter, cd enter, right? So ls. Now here I'm going to create mkdir, right? To see the use case for the rebase, I'm trying to create a separate repository, right? Because we have done merging on this git merge repository. So I would like to show you the rebase stuff, right? For that I'm going to create a separate repository with the name git rebase, some name. Convert into repository cd git rebase, right? So to convert again the git init is the command, correct? So now the same process I am going to repeat, right? So git add commit, right? So now here the same process, right? So I'm not going to explain it one more time here, so we can understand, right? A.txt is created, one commit is going to generate, when the moment commit is generated, obviously a branch will be created with the name master. So now here I am going to generate one more history, nothing but I am going to create one more file called b.txt. Then I'm trying to add it. Then I'm trying to save it. Now git log, you can see two entries and ls a.txt. The same exercise, no difference here. Now at this moment, I'm going to create a future branch. Git branch future. Right. So now the same two files along with the history will be copied into the future branch. Nothing but a replica of master. Right. So now again, I'm generating the history. Right. So on the master branch, we are trying to generate the history which should not be present on the future branch. Our intention is what are the changes I'm trying to perform now, those should not be reflect on the future branch. So now touch c.txt, then add added c.txt, save. So now on the branch master, we are going to see three commits. Now this commit is not going to present on the future branch because at this moment we created the future branch. That is fine. So now let's switch to future branch and perform the changes. So now git checkout, git branch, right? We are on the future branch. So now here I am trying to perform the changes on the future branch. So now here adding a line to the a.txt file, git add, then git commit, right? So then the same, adding a line to the b.txt file, then commit, add and save. Correct. So now git log, we can observe here two more entries will be generated for the modification of b file and for the modification of a file. At this moment, these changes are not going to reflect on the master because we are not yet merged the future branch into the master, right? That is fine. So now go to the rebase tab. After done the changes on both master and future branches, go to the master, right? So just for verification, simple, that's it. Now go to the master, git checkout master. Now see the log, git log -1 line. At the moment, we can see on the master there are three commits, one for the a.txt and one for the b.txt and one for the c.txt. Commit A, commit B, and commit C. Commit A, commit B, and commit C. Now on the future branch, git checkout future branch. Now git log -1 line. Right, A and B came from the master, and E nothing but the modification of A file, modification of B file is nothing but the commit F. Right? These two commits are not going to present on the master because it is not merged, and also this commit is not going to present on the future because this is not merged to the future. I mean, right? We are good. Now, now, now here run the command git rebase with the master. Okay, right. So now here run the command git rebase with the master. Now here I am in the future branch. Now I'm going to ask the git to rebase the future branch with the master. Now we'll see what will happen with the rebase. Okay. So now I'm going to ask the system to rebase my future branch with the master. Right. So now git rebase master. Rewind the head to replay your work on top of it, applying commit E and commit F. Modified E. Right. So now here it is trying to sync both the master and as well as the future branch. the changes are going to reflect on the other branch also. The rebase is nothing but it is trying to make synchronization between the branches. Right. So now here gate log hyphen one line. Now you can see here A, B, C are from the master branch and E and F came from the future branch. When the moment I said rebase, it bring those two changes from the future branch. Right, it is going to reapply, right? The applying the changes into the master branch. Whatever I am trying to ask the system like to rebase my future branch with the master. Right. So now here I am going to merge now. Right. So now I am going to merge my future branch into master. Right. So now to merge future branch into master. Right. So now you should be on the destination. Git branch. Right now I am on the future branch. So right, let's switch to the destination master and try to merge the future. Git merge future. And now when the moment I said merge means the commits are going to move, the data is going to move from the future to master. Right. So now try to check the logs on the both the branches. Now I am on the branch called master. Git log hyphen one line. A, B, C are from the master branch. E and F are from the future branch. Right. So now here at the moment when I said the rebase, it applied the branches like the commits. Now here that is point to the future. I can see master here. Now when the moment I merge, both become in a single line. Master and future are pointed to the head, the latest. Here only the future will be the latest, not the master. When the moment I merge it, both are synchronized. Then I can see future and master both are in the same location. Means both are pointed to the latest. Nothing but the b.txt. Right. So now, okay, fine. Because I asked the future to merge into the master. That is the reason all the changes of the future are merged to the master. That is the reason you can see apart from the ABC, E and F also came into the master branch. That is fine. ls cat a.txt. You can see the changes. Now try to switch to future branch. Git log hyphen one line. See here. Right. So now the observation, guys. Two observations we are going to find. One is in our previous case, nothing but the with the merge, with the git merge. When the moment I ran the commit command, sorry, I mean to say when I ran the git merge command, git merge future, one more commit ID is generated for the merge, right? So that is right. So now here if I see, if I go to the diagram, the pictorial one, a G is generated when we ran the future to master merge, a new commit ID. In the rebase, we are not going to see any new commit ID for the merge. I ran the merge, but you are not going to see any new commit IDs, right? Only A, B, C, F, no G, right? So if I see in my previous case, where is the one line? Git log one line, git rebase, git rebase, git merge, right? So here, this is the merge one. Now here you can see for the git merge, we can see the merge branch, future merging into the master. This is the commit ID, right? A, B, C, E, F. Apart from the F, you can see one more commit ID for the git merge, right? But here we are not going to see any separate commit ID for the merging. For the merging, we are not going to see any separate commit IDs. So that is the reason here we can find only A, B, C, E, F. That's it, no G. Right. And also the second observation. The second observation, the c.txt file which is present on the master branch is not going to reflect on the future branch until unless you merge it. Correct? So that one we have observed in our previous case. There on the future branch we don't have any c.txt file. But here, when the moment you run the rebase, that's what I told you. It is going to synchronize both the branches. Right. So now here you can find on the future branch the c.txt also. Right. So right. So now here, if now I am on the branch future ls, we can see the tc.txt. Even though I did not merge my master to future, your rebase will take care of it. Right. So when the rebase we are going to use, right? So when you want to make the synchronization between the two branches, like my master and the develop branch should be always in sync, suppose. So then after the sprint is closed, right? The sprint is nothing but like now 28. Suppose next month 1 to 15 is the my sprint time, right? So now here people are trying to do some changes, and they will push the changes into develop branch, and your CI/CD process is going to trigger. Then the CI/CD process nothing but let's validate the changes on the develop branch. Then once you are good, move the changes to the release branch, then validate it. Once the QA is given the sign off, then move the changes to the master branch from the release to master, suppose. So now here at the end, once the sprint is closed, now the developers are going to take the code from the master usually. But in our project, we have a criteria like master branch should not be touched. Master branch should not be touched. Always the code has to be taken from the develop branch. So now in the case, we should make sure like whatever the data is there on the master branch, it should be there on the develop branch also, right? So now we got a question like, anyway, the develop branches are going to the master branch. Why should we make sure the synchronization? Because only the dev branch we are going to validate, then the dev branch code will be moved to the release branch, and the release branch code will move to the master branch. So means obviously the dev code will be there in the master. Then why should I take care of the synchronization? Right? Yes, we require the synchronization when, right? As I told you sometime back, there is a chance of, even though you tested thoroughly on the dev environment, Q environment, and staging, you are going to face an issues during the deployment of the production. By that time, during the window, you have to fix it out. If it is a development change, then immediately what they will do, they will take the code from the master to hotfix. On the hotfix, they will perform the changes, and the changes will merge to the master. Now, whatever the new changes are performed during the deployment of the production, those changes are not going to reflect on the develop branch. Correct? Then, when the people are in the next sprint, when the people are trying to take the changes from the develop branch, obviously they are going to miss those changes. It's a common real-time scenario for us, right? So now you have to make sure that the DevOps folks, like we, have to make sure both master and develop branches are in sync after the sprint is closed. There we are going to run this commands, git rebase, right? Git rebase with the develop branch, master to develop, so that both it is going to automatically synchronize both the changes. Then you are going to merge the master branch to the develop branch like this. Then we are going to make sure both are in sync, right? So there we are going to use the rebase, guys. This is a real-time example for you. Okay, right? So now let's see the pictorial way of that rebase, how it is going to merge the code. Right, this is for the merge, and here this is for the rebase. Now ABC from the master. Then when I run the rebase, now they are merged to E and F. The finally your future and master on the same line. That is the reason you are going to see all the changes on both the branches like future and as well as the master. Right. So the same thing we can observe here also. Future and the master. I am on the future branch. I can see both are same. I am on the master branch. Both are on the same. It will take care. Who will take care? Our rebase will take care. We don't bother about it. Right. So this is one of the important for us guys, for the particularly for the DevOps folks. Right. That is the real-time case where exactly we are going to use the rebase. This is also a mandatory entry question for us. For in the Git sec, they will ask you what is the rebase, where you are going to use the rebase. This is the scenario you need to tell, and how the rebase, right? This is the example you need to, like, example is not required, but anyway, you have to tell that rebase is going to make sure it is going to synchronize both the branches, right? So this is the one case with the rebase, like, to synchronize both the branches. Like with the rebase, we can play many things, right? So in out of that, we'll take one more example, one more case with the rebase. As I told you, we can rearrange the history, right? We can shuffle the history, right? With the rebase, apart from the synchronization between the branches, we can change the history, we can shuffle the history, right? So how we are going to shuffle the history, right? So let's see with the use case. So how we can change the history of any branch, right? So let me take this one, git branch. I am the future branch. Git log hyphen one line. F E C B A. Now this is the order. Okay, my history is order like A B C F. Now I want to shuffle the history. Means I want to make the commit E as a latest, and commit will be F will be followed by the E. Now commit F is the latest. Then commit E is following the F. Now I want to make the commit E as a latest. I want to move the history. I want to shuffle the history. Right. So now if you want to shuffle the history, there we are going to use the git rebase. Right. So now git rebase hyphen I. When you want to shuffle the history, the command will be git rebase hyphen I, and head. Head is nothing but your location, your cursor location. You can treat it, suppose it's a cursor, then your cursor location, head, nothing but the latest. So now from the head to how many commits you want to pick, right? So now here if I give tilde 3 means from the head, it is going to pick the 3 commits, 1 2 3, like that. If I give 5, it is going to pick the 1 2 3 4 5, like that. How many commits you want to pick, and how, like, what are the commits you want to change. Suppose I want to shuffle these 2 commit IDs like this, then you can pick only the 2. I want to shuffle these 3 commit IDs, then pick the 3, like that, right? So now here I am going to run the command git rebase hyphen I head tilde, so that I am going to pick the latest 3 commit IDs. Yep, easy. Enter. Now you can see F E C from the latest to older, right? Modified B, modified A, modified, right? So now here you can see, as I told you, with the rebase you can play many things, right? You can pick, you can use the commit, you can use but edit the commit messages, reward. You can modify the commit messages, right? You can stop amending, you can scratch, you can drop, you can reset, you can merge, many things. These are options you can perform with the rebase. But what are the operations you are trying to perform? You need to make sure the conflicts are resolved. Otherwise, it's a mess for us. Okay. So better to avoid working with the history as much as, okay, when required, and play with the history. So now here I am going to shuffle my history. Nothing but I want to make the F is the latest one right now. The latest one is the F, nothing but the 715. I want to make the E or C as a latest. So let me move the C as a latest. So right, so I am going to copy. It is gone. Let me take it again. Right. So here I am going to copy. Then I am going to paste it. Then I am going to remove this one. Right. So now I made the c.txt as the latest. Right. Earlier F is the latest one. Now I made the commit C as the latest. Just I moved the C from the folder to here, shuffled. Right. So then save it. Successfully rebased and updated. Now git log. You can see commit c.txt, right? Earlier commit F is the latest. Now the commit C becomes the latest, right? F becomes the older. Here F is the latest. C is the third place here. Now the C became the first place. E moved to the second place. F moved to the second place. third place. Sorry, E moved to third place, F moved to the second place, then C became the latest. Likewise, we can shuffle the history also. Right. So when we are going to shuffle the history, right? So most of the time we are not going to shuffle the history. It is not required also. The rebase is the one which we are going to use, but not we are going to shuffle the history. But yes, there is a sometimes we might require, right? Yes, we have an option. Right? We have an option of if we want to shuffle the history, yes, we have an option with the help of the rebase, we can shuffle the history. Right? So if you need to tell these two cases, right? What is the rebase and what are the options we can claim is just to give the two examples. That's it. It is more than enough in the interview. Okay. In the real time, we are going to use the rebase, not something like this shuffling. Okay, and other options. Right, guys. So this is about the rebase in our Git. Right. So any doubts on the rebase side? Any doubts? Let me know, guys. So I will explain one more time. It is important for us. Otherwise, I will move to the other topic. Okay. Right. So fine then. So let me go to the other concept of Git 4. So now here, what is a Git forking here? So now here the Git forking is nothing but when you want to take the data from one repository to another repository, right? When I want to take the data from one repo to another repo, what we did is we have used the remote path. With the help of the remote path, we have copied or moved the data from one repo to another repo, like the branch. Here specifically the branch movement. Now here I want to take the entire repository, including the branches, into my account. Right. So now here one account of one, right. So the repository from some other account I want to copy into my account. Right. So now copying the repositories here. Earlier we have seen the branches movement. Now here copying a repository from one account to another account. That's what here the fork. Right. So now how the fork is going to work and how we can copy the repository of one another account into our account. Okay. So for that we require the other fork, the other guy, some other guy. Other fork means some other guy account. So now here let me take I'm trying to searching for some other repositories. Now we can see here. Okay, not my account. GitHub.com Kubernetes up and running examples here. Right. So here this is not my account. Examples, cur, hello world, Docker files, inflex, inspector. Total 6 repositories are there here. Kubernetes up and running. This is an GitHub account. Right. So now open the other person repository account and whatever the repository you would like to copy into your account. And suppose I want to take this Docker files. I want to take the Docker files repository into my account. There are some Docker files here. Right. So now here you can see there is an option called fork. Okay. Right. So now here this Docker files is not present in my account. This is my account, and here repositories. There are n number of repositories present here. If I search for Docker files, I think I have copied some other person Docker files. Okay, some other one Docker files is available here. Let me take the other repository because the Docker file is available here. So let me take the some other one inspector. Whatever the repository, it can be anything. Here no content is available. Hello world. Let me take the code. Right. So here this is a code is a repository. Like let me search in my repository list. Nothing, right? It is not available, right? You don't have that particular repository. So now this repository I want to copy into my account. So now simply what you do, open the repository. There you can see there is an option called fork. Simply click on the fork. That's it. Right. So now here if you have multiple accounts, and then it's going to ask you to which account you want to copy it. So now this is my primary account. We'll see how to create a multiple organization here. So now this is my primary. So I'm going to select the primary one. Right now see here the forking is happening. Right. So now here you can see this is my account. Under my account, I can see the card. So earlier it was not there. Simply now I got this one. So now here, if I go to my account and select the repositories, then search for that repository, you got it. Right. So likewise, we can take the repositories of one account to another account by using simplest option of fork with the GA. Right. But here the point is here is we can take the public repositories, not the private one. Right. So my right now my organization, what are the project I'm working here, right? So those projects I cannot take into my account, right? So here usually the projects are not able to copy into your accounts because these will be the private repositories. We are going to create the private repositories so that which you are not able to fork it. So now the public ones, yes, the public ones can be forked out, right? So because there will be no restriction to copy the public repositories, but not for the private ones. Again, that is also the option will be there if you want to fork the repository or not. So with the right, so it is available with the paid versions, not for the free versions. They are not going to give the fork option enable or not. For the paid versions, you are going to have that kind of option that you can select if you want to. You can give the access to the other folks so that they can copy your repository into their accounts or not by enabling the fork option. So that you are going to see the fork option will enable like this. Then you can simply can click on and you can copy it. Otherwise, for the private ones, you cannot fork the repositories. Right. So likewise, right. So right. So when you want to copy the repositories from one account to another account, very easily you can done by using the fork option. But those are the public ones, not for the private ones. Right, guys. So this is how we are going to copy the data between the accounts with the help of the fork. Then already have covered it. The conflicts. Then managing the repositories and the teams. Right. The management activities. Right. So as of now, we have seen creating a repositories. On the repositories, we have played many things like creating a branches, data movement, merging histories, reverting the histories likewise. But right, so now here, who is going to create these repositories? Right. Then who is going to provide the access? Like earlier, we will be having an admins. Those guys' duty is to when the people wants to have the access for the repositories, they are going. We need to raise a request. Based on the priority, they are going to work on the request. Then they are going to provide the access to us. So now everything is changed. So now there is a no separate administration team. to handle this kind of request. Everything should be taken care by the DevOps only. That is also our responsibility. Right. So now here, once we got the project, right, the projects are like two types. One is a scratch, and the second one is maintenance project. So if it is a maintenance project, everything will be implemented upfront. Now you are going to maintain it. So there you don't have to need to do this kind of activity because already the setup was done. From the scratch, when you are trying to implement the project from the scratch, everything is our responsibility. Nothing but creating organizations, creating repositories, creating the teams, giving the access. Everything is our responsibility. Right. So now here, how we are going to create the organizations. Right. What is the purpose of organization here? Why should I create an organization? Right. Easy maintainability. Right. Now the client can have multiple business units. Now to maintain the business units, instead of placing everything in a single place, I'm going to segregate into categories. My retail, for the retail business, separate retail organization I'm going to create. For the insurance, as an example, guys, for the insurance, I'm going to create a separate organization so that the insurance repositories are going to place in a separate location. The retail repositories are going to place in a separate location instead of clubbing together in a single place. Right. So now when the different business units are going to maintain by the client, so now for the easy maintainability, we are going to create the organizations. Right. So now here, how we are going to create the organizations. Right. So now once we create the organizations, before going to create the organizations, right, now the organization purpose is to maintain the segregation. Now what we are going to do here is, once the organization is ready, then under the organizations we are going to create the repositories, and we are going to create the teams. Now the teams are going to attach to the repositories. Now the people will be added to the teams. That's it. Now the access will be like that. Right. So now let's see how to create the organizations, and under the organizations how to create the repositories and the teams and the access levels. Right. So let's go. So now here this activity will be done by only the admins, not by the developers or not by the testers or not by the normal software engineers. Right. The persons like the leads or the senior DevOps folks, those guys are going to play these activities. Nothing but those guys are going to create these activities. Right. So now here, now to create the organization, we are going to go to our account. Now this is my account. Okay, this is my office one. So let me sign out and go to my local, my one. Sign in. Right now here I would like to create the organizations. Right. So now to create the organizations, we need to go to our account. There you can see there is an option called settings. Now go to the settings. Now here you can find a option called organizations. Now click on the organizations. Right. You can see here there is an organization called Visual 2020 March something. Right. So now here I want to create a new organization. Click on new organization. Now here the plan. Right. Now it is a like how the organizations are going to use. Like the team is going to use the organization, like the enterprise is going to use the organization, or just for practice purpose you are going to use, like free. Right. So now here in the free, if I take the free one, these are the features like unlimited public and private repositories can be created, unlimited collaborators, 2000 actions minutes, 500 MB of the GitHub packages for support. Now here 2000 will become as a 3000 when there is a team. Reviewers are going to add here. There is no reviewers here. Now 2 GB. Now 500 MB become as a 2 GB. Now code warners. Now here 50,000, 50 GB advanced auditing, SAML authentication. Like, now this is the charge. Right. So now here based on the purpose, we are going to choose the plans. Now here I would like to go with the 0. Now here 2000 actions, GitHub packages where we are going to use. Correct. So now the 2000 actions are mean nothing but the Git also providing the CI/CD, continuous integration, continuous deployment. Right. Means you don't require to take any third-party tools like Jenkins, Maven, blah blah blah. to set up your CI/CD, I will provide you the options. I will provide you the service for you with the name called GitHub Actions. Now, with the help of the GitHub Actions, directly you can set up the CI/CD on top of your repositories. You don't require to go with the third-party tools and collaboration. Right. So now here, this is the part of the actions mean, like how many, like suppose if I ran the job is taking 20 minutes of time, right? So now here, if I take 2000 minutes means 2000 by 20 minutes 200 minutes, right? 200 times I can run the job. If I'm trying to run the 200 one time, it is not going to allow me because my limit is raised. Likewise, they are going to restrict when you're going to use it, right? And also packages, nothing but your artifactories, right? So now here the GitHub can be used for to store the artifactories. Like normally we'll be having a third-party tools like Nexus, JFrog, like that to store the artifact. Now the GitHub is going to provide a service called packages so that you can store the artifacts. Now the space 500 MB is going to provide you for free. 2 GB is going to provide your team for 50 GB for the enterprise, like that. So like that they are going to charge. Right. So now here the GitHub actions not succeeded. Right. Even though they launched in the market like last year December or something, but it is not succeeded like our normal series. Like there are some glitches are there. So that is the reason it is not much succeeded. Okay. Right. So now here let me go to the join for free. Now here your organization name, right? So now here I am going to give AWS DevOps AWS something already taken 2020. So now your contact email. So now my contact, right? So any information, any updates for the from the GitHub side, they will contact to this email. So now, right? So what is the purpose, right? Is a business or institution or my personal account? This organization. Suppose I want to go to my personal. Next. Now welcome to GitHub organization. Now here, right? Who is going to maintain here? The person RAKNS000. Now, right? So now if the person is on leave or something, then who is going to maintain, right? So now, so for the reason, we can ask more people to add as an organization member to maintain this organization. Then from here, you can add the people. Search by username, full name, or email address. Right? Likewise. So now here I don't want to give any other one. So simply I'm going to come to the setup. Now here we can see my organization is ready. Right. So now welcome to something. Now here, let me go to my kind of, do you have existing repository for your project? Right. So as of now, submit. Now we can see here DevOps AWS 2020 organization is created. Right. So now here the people. Right. So now here only one guy is there, nothing but I am the one. I am the person. Right. So now here the packages you can see. Just now we discussed about the packages. Now the repositories. As of now here under that we are not having any repositories. Now if you want to invite any people to maintain the organization, from here we can invite. Now here I'm going to create a new repository. Sample report. Right now here public or private, we know these options, right? So I'm going to make it a public and create a repository. Right now here I have a separate organization called DevOps AWS 2020. Under that I have a repository called sample-report. Right. So now here the same process. Here the repository maintain everything, the commands and everything will be the same, but this repository is going to belongs to DevOps, not to the my account. Right. So now let me go to my account here. Again, go to the settings. Now go to the organizations. Now you can see there are two organizations. Right. So this is just now I created. If I select now, this is my personal one. If I select one, I can see the two organizations. Right. So now here the organizations can be created like created like this, then I can add the repositories under the organization. So now let me go to my organization. Then here I would like to create the teams. So now who wants to type the part, right? The repository is ready. Then people needs to work with the repository, right? So now the people means the teams, the development team, testing team, or some other teams, right? Whoever wants to have the access, they need, right? We need to provide the access to the repository for the people, right? For that, instead of giving an individual access, we are going to create the teams. Go to the teams. Then here, scroll down. You can see a button called New Team. So click on the New Team. Now here my team name is Developers. Right. So now here I am going to create a team under this organization. DevOps AWS 2020 under the org. I am going to create a team called Developers. Right. So now here the team visibility, visible or secret, right? Usually it is visible. So now select create team. Right. So now here the team is ready with the name called developers. Now I need to add the people to the team. Right. To add the people to the team, here you can see members. Here you can see the plus symbol. So click on the plus symbol. Then here you can invite the people. Right. So you can invite the people as something like whatever the IDs will be there. I can send a request to the IDs. Right. So now here I am going, or you can use the username or email something. Then already he is already member into the team. Right. Already I am the part of the team. Right. So likewise I can add the people by taking the IDs. Then when the moment I click on invite, so now a email will be sent to the people. Then they need to accept it. Then he will become as a part of my team called developers. Likewise, we can add the members to the teams. Now the team will nothing but the developers. Right. So now here, let me go to the repository section. Right. So now as of now, to the developers team, no repositories are added. So now here, I am going to add a repository. Add a repository, search for the sample. Now you can see a sample repository. Click on here, then add the repository to the team. Select. Right. So now here, the team, the developers team are attached to the repository called sample repo. Right. Now whoever there in the team, they can access the repository. Like now here, what kind of access you want to provide to the team. Right. So now here that can be decided here. Read access, trace, write, maintain, complete access admin, like that. Right. So now they can read, they can clone, they can push, right? Because the developers are going to work with the repository. They require the clone and push and other stuff. Otherwise, here if I take the read, they cannot push the code. Just they can read the code. Right. So I'm going to give the write access. Means they can clone the code and they can push the code back. Right. So now here I'm going to go to the teams again. Then I'm going to create a team. Testers. Sorry. No, not add a team here. I want to create a team. So this will be added to the developers team, right? So now I don't want to add a team here. So simply I will go to the DevOps organization, and here I want to create a new team. So right now I have the developers team. I'm going to create a new team here, and my team name is the testers. So now this testers create the team. Right now again, we can add the members to the testers, the same process again. Right. So now the testers team needs to have the access of the repositories. So now I'm going to select the repositories. Then here I'm going to click on add repository. Then I'm going to select the sample repo. sample repo, then add it. Now these guys don't require the push access because the development code should not be touched by the testers. That is the reason I'm going to give read access only. I'm not going to provide any write access. Just they can take the code into the local, they can perform, they can run the test cases, but not to modify the development code. That is fine for me. Right. So likewise, we are going to create the organizations. Under the organizations, we are going to create the repositories. Then we are going to create the teams like developers and testers, and we are going to add the team members once the teams are created. Then we are going to provide the access to the teams, the developers or testers who are going to add. So what kind of access you want to provide to them for the repositories. Add the repositories and provide the access. Right. So now here, if I go to my organization back, go to the setting. Yes. Now here, once the project is done, right, then we don't want to maintain the organization anymore. Simply we can leave it. So that is going to remove the organization from your account. Right. So you are the last owner, delete the organization. Cannot leave without 21 if you are the last owner. Right. So now here, first thing will we need to clean up the internal stuff, whatever is there, then clean up the organization. Okay. Right guys, so in this fashion we are going to create the organizations, we are going to create the repositories, we are going to create the teams, we are going to assign the persons to the teams, then we are going to assign the repositories to the teams, then we are going to give the access to the repositories. Right. So now those are all explained here. Creating organizations, creating the teams, right, giving the access, new teams, everything I explained here, adding the people, giving the users, right? So now here, collaborators, settings. Okay, there is one more option there. Let me see. Let me go to my organizations. DevOps, repository, settings. Okay, or else not, nothing is here, no content is here. Let me go to my own account or go to any one other repository, DevOps report, and go to the settings. Where if I scroll down here, if I go to the end, I can see danger zone, right? So if you don't want to maintain the repository, simply can delete the repositories. You can transfer, you can archive, you can change the visibility, right? Or finally you can delete the repository. This is the last section, so that we can delete the repositories if you don't want to maintain. Right. So here there should be a collaboration option. Actually, I think they have removed it. Under your repository, click the settings, and here we can see collaborator and teams. We are not going to see that option anymore. Okay, so usually actually earlier we are going to have an option called collaborators, but anyway right now it is not available. So discussing also waste of time, I think. Right, normally what will happen? So sometimes a use case. With the use case, I am going to tell you guys the collaborator option so that you will understand clearly. So maybe for the free account, they have removed it. It will be available for the private paid accounts. The option will be. Okay, so let me go into that way. So I will log out. I will log in with my project account. One of the repository like scheduler. What are the repository? It can be any name. I don't have the settings option here. Not this one. This is some other guy account to enable earlier. So let me take loyalty configuration. Settings. Settings. Repositories. Suppose if I take any repository for DevOps. There should be an option of collaborators. I'm not able to recollect the option, guys. Give me 2 minutes. Let me verify the options. So campaign settings. C plus integration webhook branches. Security manage access. Manage access. And here yes. So this is what collaborators. Right. So it will be right outside of the collaborators. Correct. So now here it will be under the manage access. Let me see our public account. Sign out. I will go to my own account and see whether the option is available there or not. Okay, let me log in, sign in. So I will take any one of the repository, DevOps repo or something. Go to the settings, repository settings. Then here we have an option called manage access. Yes, we have an option, right? In public, right? For the public also we have an option. So right here you can see invite collaborators. So now this collaborator option is nothing but giving a access to the person to this particular repository, right? So here this is my repository DevOps repo. Now I'm trying to give a access to the people. Right, when we are going to give, like, because anyway we'll be having the teams. In the teams we are going to add the people, and the teams are going to give the access to the repositories, right? Anyway we are going to provide the access there, but where we are going to use this collaborator option exactly, right? So collaborators can be used for the temporary purpose, giving an access for the temporary to the people. Those guys are not part of my project, but I want to give access to my repository for a period of time, like 1 week or 15 days. So by that time I don't require to add the people to the team and add the people to the repository like that. Simply what is the repository they need the access, I will go to the repository. Under the repository settings I will go to the manage access. Under the manage access there is an option called collaborator. There I'm going to add the person. right? So now here, what is the advantage here is, right? So when, right, again, not the advantage, when we are going to give the people, the other folks, to our repository access. Like we have seen, like in my previous company, I have faced the situation, right? So now here, my team is working on application, right? So now the application is working fine, no issues, but the problem with the application is performance. So now what happened here is, earlier the application is responding less than 5 seconds. When the customers trying to connect the application, trying to access any web page, less than 5 seconds it is responding. Now when the new features or something is adding into the code later on, now we have observed that the response time is increased. Means the performance is downgraded. Usually the less than 5 seconds of the response time of application becomes 10 seconds. 10 seconds means very huge, right? So it has to be respond less than 5 seconds, but it's become 10 seconds. Application working fine, no issues, but the application performance is degraded. Now our project, my project team leads, managers sit together and trying to figure out the issue, but still they are not able to figure out the issue. Now my management like came up with a solution like, okay, now this situation will not be handled by your team because you people are not able to figure out the issue. Now the some third person has to be involved here. They have to observe your code, then there is a chance of they can figure out the issue. Right. So now here the third person requires the access of my code, my project code. Then only they can see, they can review the code and they can identify the issues. Right. So now what we did is, we have given the access to the third person for a period of time. Right. They ask for the project access for 15 days or something. Right. Now here we are not added those folks into the teams. Simply we have added them as a collaborators. Now they, like, once they are done with the job, simply we have removed from the collaborators. Likewise, some scenarios will be there. By that time, we require to give the access to the third persons, which are not belongs to our project. Like this is the case, right? So this is the option, right? So you can invite the collaborators, then you can give access to the people, like read access or write access to the people based on their requirement, right? So this is one thing, guys, to managing the repositories, teams, organizations, and access to the people. Then in our starting of the git, I told you, right? So git can be classified into three. One is git to maintain the versioning and everything on the local. Simply we can use the git, right? So when you want to collaborate with other people, when you want to work with the team, there you should share your code, then only it can be possible, the collaboration can be possible, otherwise no use, right? So there the git is not sufficient because the git is going to maintain the versioning on your local only. Now we are going to use the remote, nothing but the GitHub. The GitHub is so that with the help of the GitHub, the people, the team can be share their code among themselves. So now the problem with the Git, not the problem, guys. Now the people, the client will think about the safety. Always they are going to worry about the safety, the security, right? So now if I give the code to the GitHub, like somewhere the data center is there, I am placing my entire code is there. No means what is the security for me? Even though they are providing the security to me, but something is like so some doubt in my mind, like whether they are not going to steal my code, right? Because I have given the code to them, right? What is the guarantee that they are not going to steal my code? In that cases, they are going to give an option of GitHub Enterprise, right? The third one, right? Means you are going to set up the GitHub on your on-premise machines, on-premise servers. Then you are going to maintain the GitHub from your end. No one is going to maintain. Now the GitHub will be maintained by the GitHub folks. You are not going to worry about the GitHub server, right? You are not going to worry about the patches. You are not going to worry about the backups. Nothing to be worried. Simply manage the code and use the code. That's it, right? Now here, if you have a doubt on the security side, then they are going to give an option of GitHub Enterprise. Apart from the security, they are going to give more features to the GitHub Enterprise. Like we have seen, right? The GitHub Actions time can be increased. A lot of the time can be seen on the GitHub Enterprise. And the GitHub packages, 50 GB of the package can be stored on the GitHub Enterprise, not on the GitHub or not on the free. Right? Likewise, they are going to provide many features to the GitHub Enterprise, but it is costlier one, right? So now the clients, whoever is wants to have the secure and whoever wants to have a more features, they will go with the GitHub Enterprise. So when the GitHub Enterprise, we have taken the GitHub Enterprise, then the maintenance is our responsibility. Now the GitHub is not going to maintain the uh, GitHub for you. Simply they are going to give the package for you. Now you are going to install the GitHub. Then the rest, maintain the repositories and everything, and also maintain the server also your responsibility. Now they are going to release the packages, the features on the community. Now your job is to update the GitHub. Now as of now, GitHub is running with the version 12. Now tomorrow they are going to launch a new feature, 12.1. Now you are responsible to update the feature. The GitHub, they are going to maintain, they are going to take care of the updating of features. Now here our responsibility, because they are giving the GitHub to us dedicatedly. Now take care whatever you want to take, right? So there, right? So sometimes, not sometimes, you are going to see we are going to work with the GitHub Enterprise also, right? So now here the stuff will be the same, the content, the concept, everything is same. Now the maintenance part. So we are going to see the maintenance part of the GitHub Enterprise. Okay, the rest of the options are same: creating the teams, organizations, repositories, working with the repositories, the commands, everything is same, no difference. Now the here the only difference is the maintenance. If the GitHub Enterprise is on your server, on your on-premise server, then our job is to maintain the GitHub Enterprise also. Nothing but updating the patches, taking the backup, everything is our responsibility, right? So now taking the backup is nothing but simply whatever the location is there, the data storage point is there, simply you are going to take the copy of the data storage point and you are going to place the data into some other server. Simple, easiest one. So anyway, we are going to see, we are going to write the shell scripts to maintain this backups and other stuff. So that's the process we are going to see in our shell scripts. Okay, how we are going to write the shell script to take the backup and other purpose. Okay, so yeah, at some point of time, right, maybe after the Jenkins or somewhat like, so once the Rajesh and the Krish are comfortable with the Linux commands, then I'm going to plan for the shell script side. So when the shell scripts are required, by that time I'm going to cover. Right now the Git is not required the shell script, and as well as our Jenkins also not required the shell script. Right? So we'll plan for the shell scripts after the Jenkins. Okay, anyway, I'm going to cover, no worries. So now here the part will be the update, GitHub Enterprise update. So how we are going to update the enterprise versions? Nothing but when you are going to maintain the GitHub on your on-premise. Right. So now we know, like usually we are going to get the packages from the community, from the GitHub community. We are going to get the packages, nothing but the releases. Now we are going to, you need to take the releases and you need to update it. So now there are two ways to update the GitHub enterprises. Two ways. One is with the help of GUI, graphical user interface. You are going to have an option, direct options update. Simply can update it. The easiest way. But the problem is here, when you are trying to update the GitHub enterprise, means you are going to open the internet connectivity. When you open the internet connectivity to the server, means there is a chance of hacking. Now you are going to lose the security because you have taken the GitHub enterprise for the security reason. You don't want to give the code to other persons. You don't want to give the hackers to hack your servers. But here, if you open the internet, there is a chance, right? So that is the reason we are not going to opt for the updating the package to the GA. Now the second way we are going to choose, nothing but take the backup into some other server, then copy the backup into GitHub server, then update it without opening the internet connectivity. But yes, there are multiple ways to update the GitHub server. One is through GA, the second one is the manual process. Let's see how the package can be updated on the GitHub enterprise. Right. So now here we'll be having a menu for the GitHub enterprise, something like this. Right. So now here, if I go to my GitHub, usually I'm going to see this option, this icon, this option, our account or something. On top of this here, we are going to see separate menu for the GitHub maintenance like this. It will be for only the admins, not for everyone. We are not going to give any access to this menu to other persons. Only the admins are admins are DevOps folks. Into the DevOps, only the senior folks, not by the juniors or some other. Right. So now here, this is the option. The racket symbol is the option for the management console for the administration. So now once you enter the GitHub enterprise, There you are going to see separate menu. Under that we are going to see a rocket symbol. So now we need to click on the rocket symbol. Then we are going to see management console option. Once I click on here, a drop down will be displayed. Under that we are going to see management console option. So then there we can see settings. A bar will be shown displayed. Once I click on the manage console option, then a bar will be displayed. On the bar you are going to see settings, updates, license. Now this is the one updates you need to click on. Now here is going to show you install package when. Now only you want to install, or you can set up the time. If I click on here, it's going to show you the timeline, time also, like after 1 hour, after 1 day, after 2 hours, like that. So that you can schedule it. You can schedule the updates also. So now suppose if you want to go for the right now, select the now, then here you can see a button called install. Simply need to click on install. That's it. So automatically your GitHub will be updated with the latest. But the problem here is you are open to the internet connectivity. There is a chance of hacking. Right. So now here, suppose the patch update is taking some time, like 15 minutes, 20 minutes. Now that time, if the developers are trying to access the repositories, then what will happen? There is a chance of crashes. Right? Here you are trying to update, there they are trying to clone the code. There is a chance of crashes will be happening. So that is the reason we need to enable the maintenance mode before you are going to go for the update. So then what we are going to do here is, so suppose tomorrow I am going to plan for my GitHub Enterprise patches update. Then what I am going to do here is, today evening I am going to send an email to my entire team, my project team, stating that tomorrow at so and so time, nothing but 5 to 6, we are planning for the GitHub upgradation. So please plan your activities accordingly. Like that, upfront, we are going to send an email to the team. Then tomorrow at 5 o'clock, we are going to enable the maintenance mode first, so that if someone is trying to access the GitHub, the maintenance mode will be displayed to the people, so that they are not able to access anything. Now in the background, we are going to update something like this. Right. So here, I forget to place the maintenance mode. So let me show you here. Again, guys, this is not for all the GitHub thing. Only when you are working with a GitHub Enterprise. If the project is not with the GitHub Enterprise, nothing you are going to see here. Only for the GitHub. But safer side, I'm going to give you this options so that you are not going to face any issues if you want to upgrade the servers or something. Right. So now here, once you enter the management console mode, right, this is how we are going to see. So now when I enable the maintenance mode, when the people trying to access the repositories of the GitHub account, then simply they are going to see downtime for the maintenance, down for the maintenance. So now how we are going to enable this one means, yes, option will be there, simple. Right, here the same, rocket, click on the management console, then scroll on. Here again, I'm going to see, I have shown you updates. Will be having one more option called maintenance. So now here, when I click on the maintenance, then you are going to see an option called enable maintenance mode now or later. Just simply you need to select this option. So how long you want to enable it? In 2 hours, right? Sorry, not how long. After, like right now you want to enable it. After some point of time you want to enable it. Suppose at 6 o'clock my maintenance will be started. So means I'm going to plan for the 6 o'clock. Means right now the time is 1 o'clock. After 5 hours, in 5 hours, likewise we can schedule it. So when the moment we select this checkbox, then immediately it will be enabled. Then when the people are trying to access the GitHub, they will see the downfall maintenance. So now here, before going for the updation, we are going to enable it for the maintenance mode. Then once the maintenance mode is enabled, then we are going to update the patches, save it, then update the patches. Then once the patch is done, then simply are going to deselect it. That's it. So this is how with the GA we are going to update the patches for the GitHub Enterprise. Right. So now this is not the suggestible one, because there is a chance of hacking can be done because you are open the internet connectivity. Now the safest way will be always take the package into your server, or into your workstation or some other server, not to the GitHub server, right? So then establish the communication between the server, between your workstation to the GitHub server. How you are going to establish? With the help of SSH, right? Now I am going to download the package into my local machine. Then I am going to connect. I am going to establish the communication, the connectivity between my local machine to the GitHub server. Then I am going to copy the content from my local to the GitHub server. Content means the package, the patch. Then upgrade it to the CLI, to the command line interface, right? So for that, the process will be, the steps also have explained, guys. In our PPT, you can find out those steps also, right? So now here, this is the location, site location where you can find all the releases of the GitHub enterprise, right? So now we are going to have this location, right? So when the moment the GitHub, when the moment the GitHub enterprise launched a new release, we are going to find the release version under this site. June 23 is the last update, means 5 days back. Right now 28, right? 2.211 is the version they have released it. Now what is the features they have launched? Simply click on this. They will give the details, more details. They have done the security fixes, they have done the bug fixes, and no issues. So these are the updates they have done, and they have launched with the 2.2.1 release, right? Now click on the download, so that this 2.2.1 will be downloaded into your local. Right, so now I click on the download. Now you can see here, installing on GitHub on-premise servers, or if the GitHub is on the cloud, you can choose the platform. Right now, it is my own on-premise machine server. So now here, select the upgrading here. So now the package we are going to see, right? So copy the package 2.21, then go to your server. Server means not the GitHub server, your local machine or some other server. Then here, the command will remain same, right? So when you want to download anything from the internet to your local, what is the command? Wget. In the Linux, wget is the command to download anything from the internet, right? So now here I am going to download that one by using wget and the package, right? So now here is going to download into my local. So now here the GitHub releases will be having the extension as a HPKG, right? The GitHub releases will be having an extension called HPKG, the packages extension. Right now I can see 2.2.1 is downloaded into my local. Now what I will do, I am going to establish, I am going to connect from here to my GitHub enterprise server, wherever my server is located. Then I am going to copy this file 2.2.1 into our server, right? We know, we have discussed about this copy also, SCP, secure copy, right? Or WinSCP, multiple ways we can copy the data from one server to another server, right? So now with the help of SCP or WinSCP or FTP, we are going to copy this package file into the GitHub server. Now once you enter into the GitHub server, then just we need to run a command for the upgrade, right? So the command will be ghe-upgrade. So this is the connectivity to the GitHub server. Then copy the package. Then finally here git H for hub, E for enterprise. GitHub enterprise upgrade. Then this is the package name. Nothing but what are the file we have downloaded. This file. That's it. So now it will start upgrading the package in the background. Now once the package upgraded, then it is going to show you the successful message. Then you can enable the disable the maintenance mode. Enable the maintenance mode, then download the package into one of the server, then copy the package into GitHub server, then run the command ghe-upgrade, then follow the package name. So with the CLI, the package will be updated. Finally, the new version will be upgraded to your server. Then release the maintenance mode, uncheck the maintenance mode. This is how we are going to upgrade the GitHub enterprise server case. Okay. So for the safer side, I am explaining this process. sometimes we might work with the GitHub Enterprise also. The rest will be the same, no change. Only the change will be upgradations also our responsibility. Right, guys? So this is about our Git. So now let me know, guys, any doubts. We'll discuss about it. So practice is mandatory. Without practice, right? So I'm keep on telling you guys, practice, practice, practice. Right? So see, that's what. So I am trying to give you more technical stuff rather than theoretical. So if you don't practice, that's it. Right? So please practice. All the concepts are important. So what are the concepts I am trying to explain you? Those are all are important. Nothing to be skipped out. Okay, that is one thing for sure. You need to take it care. Then yes, open for the doubts. I don't see any doubts from anyone. I think we are good. At least let me know able to follow or not. Am I fast?
No, Shankar, it is good.
It,
It
it's
is good,
good,
right?
Shankar. Yeah.
Yeah.
Yeah, thanks guys. Okay, that is fine then. So now let me know, guys. Shall we continue for one more half an hour or stop it? Because it is completed. Now I am going to start Jenkins. So now let me know. Shall we start today or in our next class? We'll start with the Jenkins.
Next class we will start it, Shankar.
Okay, fine. Okay, okay, no issues. Yeah, make sure now. Please practice it. So next class, I'm going to ask you a few questions. At least respond those guys so that I will be a comfortable position like you guys are following me. Okay, so please practice it. We'll ask few questions on the Git side. Okay, and then we'll start the Jenkins. So that is not like a teacher and student stuff. It is like I want to understand whether you people are following me or not. That's it.
Yeah, sure.
Okay. Yeah. So then, yeah. Thank you guys then. So meet you on next week. Rajesh will plan our Linux commands, Linux stuff this week, right? Okay. So
Yeah.
tomorrow I will update you on this, Rajesh.
Yeah.
Okay.
Thank
Yeah.
you. Thank you, Shankar. Thank you.
Rajesh and Chris. Yeah.
Okay.
Yeah. Okay. Thank you guys then. See you on next
Thank
week.
you.
Bye bye.
Thank you.
So yeah, I'm going to share the this recording within half an hour or so.
And also,
Sure.
Shankar, do
Yeah. Yeah. Yeah.
we
Yeah. Yeah.
haven't got any of these material like the PPTs and any of
Yes. Yes.
those?
Yes. Yeah.
Here in those?
Yeah, I shared those people also. I think like I don't have your email ID. That is the reason. Maybe those was skipped. Now today I'm going to send those things to Chris.
Okay.
Materials
Yeah.
and the recording, everything I'm going to share to you today.
Thank you. Thank you.
Yeah, thanks, Chris. Okay, guys, thank you then.
Thank you.
See you on next week.
Shankar. Yes.
Bye bye.
Yes. Bye. Bye.
Have a good one, guys.
Yeah.